So, hello everybody, welcome to the channel. This is my first request video. There have been a lot of requests that I make a video about the controllers and some of the technology behind it and the parts that I'm using. And this is also the first video where I'm talking to you, so this is all new to me and I guess new to you, and I hope I don't botch it up too bad because English is not my first language, and it's still better if I do it in English than in Swabian. So let's go. I'm going to try and show and explain some of the parts that I'm using, and I'm trying to give you a short oversight why I'm using them. This is not anything too deep. It's probably better if you get to know these things yourself, because the time is too short to really teach everything that is important, but maybe I can give a short overview and you can have some understanding why I'm using these parts. And if you look at the stuff that I'm doing, you'll recognize the one or other thing and you'll say, ah, I've seen that before. So to start out with these things, I assembled some of the more commonly used Arduino parts, the controllers, and I also put the two controller boards that I made up till now for the plotters, and let's just go through it one by one. So we'll start with the Arduino Uno, which is the first Arduino, and this has an 80 mega 168 chip on it. It has 16 kilobytes of memory, and you can use it for small things, but I'm not using it often because I don't like the way the headers are at the top, because if you're going to make a controller and you want to just stick this on there and you want to have a single layer board, then you'll end up just putting the lower side up, and I don't know, I don't really like that so much. The second board, which is widely used, is the Arduino Mega, and the Arduino Mega is the power horse. It has over 50 digital in and out ports. It can do PWM on 15 ports. It has 16 analog inputs. It works with 5 volts, which is very good. And it is used by almost all the modern implementations of 3D printers and plotters. But what I'm using is this. This is the Arduino Nano. It has the 80 mega 328P chip on it, which has 32K. It has the pins on the lower side, which makes it very good if you have a board you just want to stick it on the top, and it makes it very easy to change. For example, if you have two boards and you want to switch them. Now let's look at what these things do. Let's start with the Arduino Uno. The Arduino Uno has 16K or 32K of memory. It comes with 13 digital outs, 5, that is not 5 but 5 plus 1 analog in, and it can do PWM on 6 ports. I use this a lot because, not the board, but the chip, because it has everything I need. The 16K is a bit too small, but if you get the board, you can switch out the chip. That is really easy to do. The Arduino Mega is the power horse. It has 54 I/O digital. It has 16 analogs. Analog in, that is. It does not have any analog out. And it can do PWM on 15 ports. Also, what makes it very good is it is 5-volt based, which means you can use 5-volt for everything. All the outputs are 5-volt, all the inputs are 5-volt, and since most of the other hardware that you get today is 5 volts and not 3.3, for example, this makes it very compatible with existing hardware. And last but not least, the Arduino Nano, which in my case has the 328P chip on it, which has 32K of memory. It has 13 digital out. It has 5, that is 6 plus 2 analog ins. Those analog ins, you can take the first 6 and use them as I/O ports. This is pretty neat if you want to control more than just the basic 13 I/O ports. So you still have 2 analog ins, but you can use the other ones for analog out. Let's for a second talk about unipolar steppers. Unipolar steppers are the type of steppers that you get in very cheap hardware. For example, you get them in old disk drives. They have a thing which is called a coil. In fact, they have 2 coils for every side, and each coil has a lead in the middle. So, if you want to control it, you can put your negative voltage in the middle and just put positive where you need it. So if you put positive here, you will have a magnetic field going through here, and since these are laid over each other, if you turn it around and if you put your positive voltage here, it will just turn around, which is very neat because you only need positive outputs on every controller. This makes it very easy to use them, and they're very cheap. To control those, we use the ULN 2003 chip. The ULN 2003 chip is nothing more than a set of Darlington outputs for each port. The input goes in at the left, the output comes out at the right. It has its own supply, and you don't need to worry about anything. There are freewheeling diodes in there, and you cannot go wrong with this. If you want to control a unipolar stepper, this is the way to go. When you buy these, you usually get them in a very neat package, like this one, where you have a board, where you have the controller, where you have the connectors, and you even have some LEDs to show you which of those positive outputs are switched on at the moment. These boards come at about $1 a piece, so I like them a lot and I use them. I took those exact chips and put them on this board. There are 2 of them here, and I'm controlling them with the Arduino. If you want to control something like this, it is very easy to wire up, because if you have your stepper motor with the coils and you have the controller IC, all you have to do is you have to find a set of data pins. Let's use these here. And connect these to the controller IC. And then to the stepper. There's nothing more to it. You need nothing more. You need your common supply voltages down here, and that's it. You might want to go with a capacitor or two to get rid of noise, but that's it. This is what this is. Basically, the Arduino is connected to the IC is connected to the stepper. There's a 5-volt power regulator up here, which is used if you want to connect a servo motor, and there could be a MOSFET up here if you want to control something that needs more power, like for example a laser or a heater. Bipolar steppers, on the other hand, are a bit more complicated than that. Not by the stepper itself, because it's simpler. It only has one coil per side. But if you want to change the way the magnetic field in here is, you actually have to reverse the voltage. So if you want it like this, you have to go plus and minus, and if you want to turn it around, you have to turn the voltage completely around and switch the outputs. This makes the controller a lot more complicated. The benefit of this is you can actually decide not to put 100% of voltage on this coil, but only 50, and only make the stepper turn half a step, whereas the other coil is powered fully. But this makes the electronics very complicated. For example, if we look at the common Pololu board, this is what's in there. The controller itself is very small. There's almost nothing to it. In fact, it's so small, and I can just put one here. It even comes with a little heatsink, because of the nature, these things can do quite a lot of amps, and they will then get really hot, so you need a heatsink. The Pololu board comes at about $2 to $4 a piece, which makes it very interesting, but it needs a different setup. If you have a Pololu board, to control the stepper, which is again connected to the Pololu board itself, you need only 3 signals. One is the signal to do a step, the other one is a signal to tell it in which direction it's going to step. You can even tell the Pololu board not to take full steps, but half steps, quarter steps, or 1/8 of a step, or if you really like it, 1/16. This makes it very, very versatile, and it makes you take steps in a very, very small angle. But to the controller, everything looks very simple. Just go a step forward, go 1 step backward. You need a third connection over here to the enable, because you can actually switch this thing off. So it'll power down everything that is going to the stepper. Now looking at the controller boards, if you take this controller, it is built very simple. It only has the Arduino, it has the drivers, and it has the output. I built a new version of this, which is made for the Pololu boards, and it has 3 of those on here. It has one ULN 2003, which can supply voltage to a unipolar stepper, It has a number of outputs which can do PWM. It has an output for a laser or a heater, and it has an output for a servo. The servo is very neat if you just want to have it as a plotter and you want to have something that makes the pen go up and down, or anything in between, because it's a servo. This will accept the same Arduino Nano, and it is working the same way. Nowadays you get a lot of these things where they tell you there is the Arduino Duo, for example. But just some advice from me: don't use the Arduino Duo, because they have one big drawback. They're completely based on 3.3 volts and they're not 5 volt tolerant. 5 volt tolerant means you can actually put something on here that has a pull-up resistor to 5 volts. If something is 5 volt tolerant, it will not harm it. But these things will break if you have a 5 volt pull-up or a 12 volt pull-up. Nothing should be above 3.3 volt on these things. And unless you really design your boards and controllers to handle this, you shouldn't use these. If you're really good at this, then just go ahead and use them. But think about basing your things on 3.3 volt. There are the so-called ramps boards, and I thought I had one here. I might need to go get it. There are these ramps boards. Ramps is the RepRap Arduino Mega Polulu Shield. It does the connection between a Mega controller and the Polulu stepper drivers, and it brings a lot of other useful hardware with it. It also has most of the resistors, capacitors, or MOSFETs to drive and read temperatures, or drive heaters or fans. This here is one of these boards. Now you can use one of these boards with most software around and out there, and use it to control steppers and all the other things. You can use it to control servos. It's all on there. If you want to go for something that you can get everywhere, you should get one of these. You can either use the standard Polulu drivers, or you can make your own set top on this and drive something else. These go in here and they work very well. But they do cost a bit more. But you will be able to do things up into the far future, because you basically have the platform for everything. Now, the new controller board that I built is very similar to this. It features all of the basic outputs you need, not for a 3D printer, but for a plotter or for a small CNC. And besides that, it has nothing more. It doesn't need a Arduino Mega to be run, it'll just run off the small Arduino Nano. It has 3 drivers. It has a driver for 12 volt Unipolar steppers. It has 3 general purpose output pins, which can do PWM. It has a driver for a servo, and it has an output for something which requires more power, for example a cutting laser or maybe a small motor. All of this documentation is also available at the GitHub found in the description of this video. This here is the board layout. Of course, it's mirrored on here. So, I hope you enjoyed this short video. I hope I was able to rectify some of the questions out there. I hope I was able to give you some idea of what I'm using. I will make another video like this one about the programming, how to program these things, and how the programs that you can download at my Git repo, how they work. And I hope you enjoy. Thank you very much. Good night.